Now we will look at required practical number 10, the investigation into the absorption and the emission of infrared. So you may remember that infrared radiation is given off by warm objects. Well, how much infrared they give off is not just dependent on the temperature of the object, but also on what the surface of that object is like. Different surfaces give out different amounts of infrared for a given temperature. This device here is called Leslie's cube, and it is basically a hot water bottle that can rotate. It's a copper box. I can take the lid off, and inside you put hot water. Now that means that there can therefore be infrared radiating out of the box. There is a device here which measures the amount of infrared, and what is very important is that it is kept at the same distance each time to make it a fair test. And what we will do is rotate Leslie's cube to present the different surfaces of the cube to the infrared detector, and you will have to make a note of the amount of infrared that is detected on the multimeter just here. So the different surfaces include a matte white surface, a shiny copper surface, a matte black surface, and a more dull copper surface. So these are the different surfaces. We will compare each of them. The first job is to fill Leslie's cube with hot water. I have to be careful here. Leslie's cube will get very, very hot. So the idea is we will have to handle it with the gloves. We'll put the lid on. It is already getting exceptionally hot. There we go. And then we'll move this into position, so come closer. So the first measurement is on the screen. This is equal to the amount of voltage that is passing through the infrared detector, and it's equivalent to the amount of infrared it is detecting. At the moment, it is pointing towards the white screen. So please make a note of this number, and we'll move on to the next screen. The next screen is the shiny copper screen that is now pointed at the infrared detector. So that is the shiny copper screen. Next we will go to the dull copper screen that is not as shiny. This is the matte copper screen. And then finally we'll go to the matte black screen. Matte just means not shiny. So here, the matte black screen. Now from these 4 different measurements, you should be able to determine which of these surfaces gives off the most infrared. Which of these surfaces is best at radiating away infrared into the environment. The second part of the required practical requires us to investigate the effect of the absorption of infrared made by different surfaces. So now we will have an infrared light shining at these 2 thermometers. One of them is silvered and the other one is matte black. And this has been achieved by dipping this one in some graphite. It hasn't changed the emissivity. So basically what we see in terms of the temperature rise is due to how much infrared radiation these have absorbed. So what we're going to do is we're going to watch the temperatures rise. There will be a stopwatch in the frame, and what I suggest that you do is every 10 seconds you measure the temperatures on both of those thermometers and then present it as a graph. And what you should find is that the surface that is better at absorbing infrared has a steeper line on their graph, and the one that is less good is more shallow. So come on over and let's watch this thing. So the one on the left is the one that is covered in the black material, the one on the right is the one that is silvered.